In this module, we will talk about a very powerful algorithm which is called the random forest. So let's dive in details of random forest and see why is it so powerful and why is it called random forests. Okay, so first let's see why is it called a forest. It is called forest simply because we build many different trees here. So in random forest, we will be building hundreds or even thousands of trees and then finally use all the trees to make a prediction. This is why it is called forest. We will see why it is called random. Now since we are creating multiple models, it is also known as an ensemble technique. So ensemble means where you create multiple models and finally use all the models to make a prediction. So first let us understand how do we make a prediction using multiple models. So random forest creates multiple trees. So let's say this is the data that we have row numbers from 1 to n. So this is our training data which has n rows, and we are creating multiple trees. Let's say we are creating m different trees. Now how would the random forest make the final prediction? So each tree, so we have seen decision tree in a previous module. Each tree will make a prediction in the usual way that we have learned. So if it is classification, each tree will focus on minimizing the impurity in each bucket using either Gini index or entropy or information gain. And if it is a regression problem, each tree will try to minimize the sum of squared error within each bucket. So using that, each tree will make a prediction. So let's write down the prediction of each tree. So for the first row, I have written down the predictions. Now similarly, for the second row, we will have the predictions of each tree and so on till the nth row. So each tree is making a prediction for the same particular row. Now finally, what would a random forest predict? A random forest, if it is a classification case, so if it is, let's say, a 0-1 case where your dependent variable is either 0 or a 1, in a classification case, the final random forest model will predict the mode of all the trees. So if you have more trees predicting 1 than zeros, the random forest model will predict a 1. And similarly, if you have more trees predicting zeros than ones, the random forest model will predict a 0. Now what would the prediction be in case of regression? In case of regression, each tree predicts a continuous value, and finally the random forest will predict the average of all those values. So if tree 1 predicts 5 and if tree 2 predicts 10, the final random forest algorithm will predict 7.5, which is the average of 5 and 10. So if you have 100 trees, there will be 100 different continuous values predicted by each tree, and finally you will take the average of all the 100 values. So that is how a random forest will predict for both classification and regression. Now let us see how are these individual trees formed. So we have seen how we create multiple models, and using those multiple models we finally make a prediction. But how are these individual models formed? How are these trees formed? Let us look that in details now. So random forest, they use a technique called bagging. So bagging stands for bootstrap aggregating. So the word bagging comes from here, B-A-G-G-I-N-G. So what does bagging mean? Bagging means random sample with replacement. So random sample with replacement. So what does it do? So let's say this is our training data. This is the data that we will use to build our models. So let's build a random forest model which has 3 trees. So tree 1, tree 2 and tree 3. So how many trees do we build? So this is what the user decides. The user will pass a parameter which will decide how many trees you have to build. So in this example, let us build just 3 trees so that it is easy for us to understand. Now, if we build 3 trees on the same data on this particular data, all the 3 trees will turn out to be the same because the data is the same, and hence their predictions also will be same. And it wouldn't it wouldn't give us any effective result, because each tree is giving the same prediction. So the average will also be the same. So what do? Instead, we use a bagged sample of data for each of the trees. Now what is bagged sample? It is random sample with replacement. So let's say, for example, we have 10 rows in our data. So each tree will take a random sample with replacement from this data. So let's pick some data points from this 10 rows of data, so with replacement. So the same rows may repeat. So I'll take rows number 1, 3, 9, 7, 8, and once again 1. So I have taken random number of rows from this data with replacement. Now how many rows will I select? Random forest takes 2/3 of the total number of rows. So 2/3 of the total number, which would be 6.7 here. So around 6 or 7 rows will be selected here, and this will be used to build the model. So the model will be built on this data. So what about the rest of the data? The rest of the data will be used to make predictions. So what data points are left? We have 2, we have 4, 5, 6 and 10. So on these rows, the model will be used for predicting. So the model will be built on this data and it will predict on this data. So this becomes the test data set and this becomes the training data set. So within the training data, you are creating a training data and a test data. So this bagged sample of data will be used to train the decision tree model, and the remaining data points will be used to make a prediction. Similarly, on the second tree, we will take some other 2/3 of the data points. So now we might select 2, 5, 9, 10, 6, 4. So these are the rows I have selected now. This is again bagged sample with replacement. So random sample with replacement. The same rows may appear or may not appear. So here this is my tree 1. It is built on this data and it predicts on the remaining data. Similarly, I have tree 2 now. It is built on these rows and it will predict on the remaining rows. So what do I have remaining here? I have 1, 3, 7, 8. I have these rows. Okay. Now similarly, I'll have another tree created which will again be on, this will take again 2/3 of the data as training data, and the remaining data will be the test data for this particular tree. So this is how different trees will be built, and since each tree is seeing a different data set, a different set of training data, each tree will turn out to be different from one another, and hence the predictions will also be different. And then you will finally take the mode of all the predictions, and you will take the average of the predictions in case of regression. So this is how random forest creates multiple trees, and each tree being different from one another. Notice that each tree here is independent of the other. So tree 1 has nothing to do with the second tree, and similarly the second tree has nothing to do with the third tree. So each tree is totally independent of one another. Now apart from bagging, so this is the concept of bagging, where you take random samples with replacement, and on these random samples you create multiple decision trees. Now random forest, in addition to bagging, it also does a random variable selection. So how does it do this? Let us discuss about this first tree that I have built here. I'll talk only about the first tree now. Now in the first tree, remember how a decision tree works. We have discussed this in a previous module. So decision tree will start creating homogeneous buckets, and within those buckets it will try to keep only pure classes, or classes belonging to either 0 or 1. Now while a decision tree creates, it will make splits, so it will make decisions. So for example, in the root node you will have the first split created, and decision tree will see which variables. Let's say we have 4 variables given to us. So out of the 4 variables, a decision tree node will start evaluating which of these variables is giving the most pure bucket or the purest bucket. So that particular variable will be selected as a split here. So whichever variable out of all variables gives the purest bucket is selected as the decision node in a typical decision tree. Now in a random forest, this slightly changes. In a random forest, instead of giving all the variables, a random sample of variables is taken. So you will not give all the variables to decide which variable gives the purest bucket, but you will take a random sample of the variables. So how many random variables will you take? That is by default root p. Root p will be taken by default, where p is the total number of variables you have. So here, for example, if you have 4 variables, I have 4 variables here. So in this case, any 2 variable will be selected. So let's say I selected v1 and v3. Now out of v1 and v3, whichever gives the purest tree or purest bucket will be selected as the root node. So let's say I select a root node of this. So v1 is less than equal to 5 and a split will be created because out of these two, v1 was giving the purest bucket. Now we move to the next node, the intermediate node. Now in this case, once again, randomly 2 variables will be selected. Now any 2 can be selected. Let's say I'll take v3 and v4 now. Now out of v3 and v4, which of these 2 variables gives the purest bucket, that will be selected for this particular split. Let's say v4 gives the purest bucket. So I will take v4 now. Similarly, for the next split, again randomly any 2 variables will be selected. Let's say it says v1 and v4 now. Out of these 2 variables, whichever gives the purest bucket, that will be selected for the split. So this is how you will have random variables selected at each particular node in every decision tree. Remember, we were talking only about the first tree here. Similarly, you will have the tree 2 getting created and tree 3 getting created. So each tree, if you see overall combining what we discussed here and here, each tree will see a different set of rows which is coming from the bagged sample, and each tree will also see a different set of columns. So the final tree that is built will be very different from the other trees that are getting built. So tree 1 will be very different from tree 2 and tree 2 will be very different from tree 3. So finally, when you combine their results, it turns out to be very powerful. So random forest, this is how it works. A very normal analogy to explain random forest is the example of Who Wants to Be a Millionaire. So the famous English show, Who Wants to Be a Millionaire, or the Indian version of it, which is known as KBC, or Kaun Banega Crorepati. So one of the most famous lifelines in this show is the audience poll. The audience poll. So what is done in an audience poll? In the audience poll, the person who is participating in this contest is allowed to have an opinion from the audience. So there are usually 4 options, A, B, C and D, and the audience votes on these options. So usually the participant selects whichever option gets the most audience vote. So let's say if this is the audience vote, the participant will obviously select option C as the correct answer, since most audience has voted for option C. Now why am I giving you this example? Because this is exactly how a random forest works. So what did each audience do here? Each audience made a prediction of the answer, of the correct answer, and finally the participant selected the mode of the answers, or the option which was selected by most of the audience. So this is exactly how random forest works, because a random forest also takes the mode of the results. So whichever tree or whichever option is selected by most of the trees, most of the decision trees, is finally taken as the final prediction by the random forest. So this is a very good analogy to understand how random forests work. So quickly revising what we have discussed, random forests are ensemble model. Ensemble because they are created from multiple decision trees. Now, how do we create multiple decision trees? Multiple decision trees are created using a bagged sample of data. What is bagged sample of data? Bagged sample of data is when you create random samples with replacement. So 2/3 of the data out of all the training data is selected to build a tree, and using that data you predict on the remaining 1/3 of the data. So this is how each tree will function, and finally each tree will make a prediction. The random forest will finally predict the mode of the results if it is a classification case, and it will predict the average of the results if it is a regression case. Now this is what is bagging. Random forest, apart from bagging, will also do a random variable selection. So during the construction of each tree, at each decision node, you will not provide all the variables, you will provide a subset of the variables which is again randomly selected, and out of the randomly selected variables, whichever variable gives the purest bucket is selected as the decision node. So in whole, random forest not just selects random columns, but not just selects random rows, but random columns as well. And hence the word random is used in random forest. Random because for each individual model you are selecting a random set of rows, and for each individual model you are also selecting a random set of columns. And forest because you are building multiple decision trees. We will see more details of random forest and how do we execute random forest in R in the next video.